Pretty good. Okay, here we go. So it says, so today we want to determine if things are functions, and we also want to learn how to graph piecewise functions. So the first part is very much review, and it says use the vertical line test to determine if the following are functions. What does the vertical line test say? What does it say? Take a vertical line, drag it across the function, and if it crosses 2 or more, then it's not a function. So, and the reason why it works is a vertical line is an equation of x equals. So we just set it on a spot, say x equals -3. How many outputs are there at x equals -3? There's only one. The output is right here. We move the line across, let's say x equals 2. There's only one output still. So you can move this line across, and every x value you move it to, there's only one output. So yes, this one is a function. Is the second one a function? No. Circles are not functions, as you can tell it crosses many times. Is this one a function? No. Last one sometimes tricks people. Is the last one a function? It fails right here. You have a vertical line, as well as I could draw a vertical line. But if you have a vertical line, that's an infinite number of points, and so it fails. Okay, so it fails right at this spot. So that's not a function either. So the only one is the first one. And math works a lot better if we have functions. In fact, calculus is very difficult to do if you don't have functions. So again, we're trying to prepare you to move into that. So we like to study these type of things. You guys have done vertical line tests for like past 5 years, right? I mean, you've known this for a long time. Okay. But do you know how to determine whether a function or an equation is a function algebraically? And the way that we do that is we solve for y. So in this first scenario is I just subtract 2x squared, -4y, equals -2x squared plus 8. Then I divide by -4, y equals 1/2 x squared minus 2. If I plug in a value for x, give me a number, any number. 3. 3 squared is 9, times 1/2 is 4.5, minus 2 is 2.5. Do you ever wonder about plugging in a number and coming up with more than one value for y? Doesn't matter what we plug in, we only get one result, right? So therefore, this is a function because we only get one result. But watch what happens for the next one. If we solve for y, we get y squared is equal to 9 minus x squared. If we square root both sides, we get y squared is equal to the plus or the minus, because square roots have two solutions, of 9 minus x squared. Well, not y squared, just y. I took the square root. Now give me a number. 2. Great. What's 2 squared? 4 and 9 minus 4 is 5. So if I plug in 2, I get the positive root of 5 and I get the negative root of 5. So if you plug something in for x, you get 2 results. So it fails to be a function. So anytime you have a y squared, most likely going to be a case where you don't have a function then, because when you square root, you'll end up with a positive and a negative value. Now, do you guys know what this graph looks like? X squared plus y squared equals 9. We graphed it last unit. Looks like starts with a C, rhymes with Urkel. Circle, there you go. So, the circle, and its center is at 0, 0, and its radius is 3. So we know that circles are not functions, and we verify it algebraically like this. So I know you can look at the graph, but can you also verify it algebraically? And that's how we do it. Last example for this one. If we solve for y, we add y to the third to the other side, and we get x plus 3 is equal to y to the third. How do I get rid of the cubed? What do I do? Cube root. So we get the cubed root of x plus 3 is equal to y. You tell me, when you take the cubed root of 8, what do you get? 2. If you take the cubed root of 0, what do you get? If you take the cubed root of negative 27, what do you get? Negative 3. When you take the cubed root of something, do you get one solution or two solutions or three? You just get one. So this is a function. You just have one result. Okay. Any questions on those two? Vertical line test, easy, right? Solve for y. If you got two solutions, it's not a function. Okay, let's do the last one. This is a little bit trickier for people, but I think we found a great way of teaching it over the past couple of years, so we'll give it a shot and see how it goes. Our last objective for the day is to graph piecewise functions. Remember yesterday we saw if you could evaluate such things as f of 0, you would plug 0 into this one because 0 is less than 2. Now what we want to do is we want to generate the graphs. Okay, I'm going to do this two ways. The first time I'm going to do it the long way. Next two times I'm going to do it the shorter way. Okay. First of all, let's identify what each of these graphs look like. What is the graph of f of x or y equals 3? What does that graph look like? Is it a horizontal line or vertical line? Horizontal, and it passes through a y value of 3. So I'm going to draw the whole thing. If you don't want to draw it, that's fine, because you are going to have to erase part of it eventually. What does the graph of y equals x minus 4 look like? That's a line with a slope of 1, and it passes through negative 4. So I'm going to draw a line with a slope of 1 that passes through negative 4. Now you tell me, as I draw both of those, is that a function? Does it pass the vertical line test? No, it does not. So what I have to do is I have to look at my domain restrictions. And I've got to cut off part of the graph. So this is the important part. You only want to look at the graph f of x equals 3. You only want to look at that graph up until an x value of 2. You want to cut off everything after that. And this graph of x minus 4, you only want to see that after the value of 2. And the way that is easiest, it seems, for students to figure that out is to find the endpoints of the graph. So I look at this value right here, 2. That's where it splits from one graph to the other, and I plug that value in. If I plug in 2, what is the output? What is always the output of this function? 3. Do you think that will be an open circle or a closed circle? Open. So I'm going to plot the point 2, 3. Notice it's an open circle. I'm going to erase everything after that. Because we're only talking about values that are less than 2. Now I'll plug in 2 to the bottom function. When you plug in 2 to the bottom one, what's the output? Negative 2. 2 minus 4 is negative 2. So then I plot to negative 2. Open or closed? Closed. Now which portion should I erase? Left or the right? I erase the left because I only want the stuff that's greater than or equal to 2. So that's my piecewise function. 2 parts, the graphs, just like we thought, but we have to get rid of the parts that are not part of the restricted domain. Okay. Let's try another example. Okay. G of x. What does the graph of x plus 3 look like? It's a line with a slope of 1, passes through a y-intercept of 3. What does x squared look like? What shape is that? Parabola, centered at 0, 0. So let's plug in our spot where the graph splits. It splits at -1. If you plug in -1 to the top one, what do you get? You get 2. So there's going to be an open or closed circle there. Closed. -1, +2, closed circle. Now, I want to draw the graph to the left from there because I want values that are less than or equal to -1, it says. So I'm going to draw to the left a graph with a slope of +1. Okay, if I plug in -1 to the second one, what do you get? +1. So you have -1, +1. Is that an open or closed circle? Open. And we said that you want to draw the parabola. And the parabola carries on. It's centered at 0, 0, and it goes on up from there. Now, I know that some of us don't remember how to graph parabolas like, vertex form, standard form, what is the vertex, -b divided by 2a, stuff like that. We're going to cover that in about, a couple weeks. But for right now, we're going to give you basic parabolas to sketch. Notice that if I draw the rest of the graph in red, okay, that's the part that I skipped from the previous problem. I just didn't draw the graph as it was extended. If you forget how to do it, go ahead and do it like we did the first one. Draw the whole graph, find the endpoints, and then just erase them after that. So if I already erased it, I'd erase the red. That's the part that would get erased. Better? Better. Let's try one more. This one has 3. We can do 3. What does 4 minus x squared look like? What does that graph look like? It's a parabola that faces down and it's shifted up 4 units. So the negative in front of the x squared means it goes down, and +4, we're shifted up 4 units. So let's find our endpoint. We plug in 1 and you get 3. Open or closed circle? Open circle on 1, 3. Now we're going to draw the parabola to the left from there, and as you draw it to the left, we said it shifted up 4 units and it goes down. So that's what the graph looks like. Let's do our middle one. For our middle one, we have 2 endpoints. What is always the output of the middle function? It's always -2. So if I plug in 1, I get -2. If you plug in 3, you get -2. Open or closed circles? Open, so I got 1, -2. I got 3, -2. And between there, the graph is just a horizontal line, we said. So that's what the graph looks like. And then the last one, x minus 5, that's a line with a slope of 1, and it passes through -5. So I'm going to plug in my endpoint. It says my endpoint is going to be 3. What's the y value? -2. Open or closed circle? Open circle. 3, -2. The circle is already open. I don't fill it because it doesn't have an equal sign. But it's from right here. Now I got to finish the graph. And some people want to draw it to the left because it passes through -5. But we don't draw that portion because we're only drawing the values greater than 3. So just draw it with a slope of 1. Head up with a slope of 1 from there. and that's going to be your graph. So again, our objectives today were to identify whether or not something's a function by vertical line test. You guys know how to do that. Then to define whether it's a function by solving algebraically. And finally, be able to graph piecewise functions. So that's what I want you to practice today. You can see that graphing piecewise functions, if we don't practice this, this is a skill you could definitely lose, right? I mean, every year people get behind on this stuff, it definitely comes to like time before test, and they're like, I don't remember how to graph these at all. I would say that, you know, graphing these is probably one of the more difficult parts of the test for people. So let's make sure that we can do that. Your assignment is right here. It's also up on the board. It's a little bit longer than yesterday, but some of these are pretty easy. It's just tell whether or not it's a function by using the vertical line test. You have the rest of the hour to work. And I ran off some packets for 2.1 through 2.5. So again, please don't take them out of the room unless you're going to return it. But that can help you get started with that. So.